Okay, if my eyes are not looking the right way, it's because I can never remember to look right at the lens. So I'm trying. So I'm going to give you a little more than just my head today. You can get some shoulders too. So I'm going to do an 8th grade lesson on solving. 7th graders can handle it too, I'm sure. So it's multi-step equations. And I'm going to need a marker and put it down. And I title it OSO because there's like terms on opposite sides. The O is for opposite. But everything is basically the same. We're going to look for parentheses. Do you see any parentheses? No. I'm going to look for any like terms on the same side and combine them. So can I add these? No, that's an X and that's not. That's an X and that's not. Over here, I have some that are both like xylophones with xylophones. The 8 is by itself. 7 and 2 make 9 X's. I didn't do anything over here, so I'm going to keep it the same. Okay, there wasn't any parentheses. I just did same side combining. Now the next one's called OSO because if I have like terms on opposite sides, then I'm going to do the opposite to get it to the opposite side. So, since I'm going to do opposites, I'll put my balance beam down. And then you got to decide which one do you want to do first, because I have 2 sets of like terms. I have X's, and I have regular numbers, otherwise known as constants. So, just because I can see the future, and I know we're going to be doing inequalities at some point that aren't equal inequalities, let's keep Princess X as positive as possible. That's pretty much a life lesson. Let's stay positive. So I'm going to focus on the princesses first. They're right here, X's. And if I want to keep them positive, then I'm going to want to do the opposite to this one. Opposite of a positive 6x is a negative 6x. Do it to the left, do it to the right so you don't cause a fight. Drop it like it's hot, see what you got. I got a 3. I got an equals, I got an 8, and a 9 minus 6 is a positive 3x. Okay, I like to focus on the princess first. Now, that is not to say there wasn't like, how many? 3 other ways I could have done that question. I could have done minus 9x, but I would have got a negative 3x, and there would have been nothing wrong with that. I just want to keep the princess positive because in my future it's going to make my life a lot easier when my princess is positive. But that would have been okay. And I could have done the opposite of the 3, or I could have done the opposite of the 8. So there was 4 different ways to do that problem. But stay with me. Focus on the X first and keep her positive. So now that my X is here on the right, Princess X wants to be alone. She wants some alone time. So we got to think about who's bothering her. 8's bothering her and 3 is bothering her. According to my checklist, we get rid of any adding or subtracting first. The 8 is added. The opposite of 8 is negative 8. Do it to the left and to the right so you don't cause a fight. Drop it like it's hot. See what you got. I got a negative 5. I got an equals. I got nothing here because it completely cancels, meaning 0. And the 3x is still there. Back to my checklist. I have multiplication and division to get rid of. I see a times right here. Well, actually, I don't see a times. It's implied. So make it visible. And the opposite of times is divide. We're going to do it a grown-up middle school way by dividing down with a fraction bar. And we're not using the dots because we're not working side to side. This does not cancel, by the way. That divides off to 1x. I can write the 1 if I want to. And I can just keep this like this, or I can write it as a mixed number. 3 goes into 5 one time with 2 left over. Middle school does mix numbers a lot. In high school, you would just leave the negative 5/3. They'll leave it improper. It'll be perfectly fine. Okay, so I'm going to review that for 1 second, and I'm not going to use the checklist over here. You need to simplify, that's simplifying, before you solve, which is opposites, okay? As a general rule. Simplify before you solve. Drop it like it's hot and see what you got. Don't move stuff around. These, see, my equal signs are all in line. Keep it in line. Okay, you need to stay in line. All right, let's check out one more problem, which is the same but different. You ever hear somebody say that? It's kind of annoying. It's the same but different. What does that mean? Okay, so let's check this out. Instead of writing my checklist right now, I'm just going to go with simplify before I solve. I could simplify this using distributive properties. So it's nice and organized when you do the boxes. I'm distributing the 3. The 3 is touching the parentheses. 3 times x is 3 times x, and 3 times 2 is 6. Let's write down what we got. I got a positive 3x, a positive 6. I got an equals, and I got this stuff over here. Looks a little interesting. So again, my personal preference is to keep the princess positive. That was a lot of P's. My personal preference is to keep the princess positive. My personal preference is to keep the princess positive. So, I'm going to look at these x's, and it actually doesn't matter which one I do the opposite of because they're the same. So I'm going to do the opposite to get it to the opposite side because we want our princesses all on one side. So, oppo of a positive 3x is a negative 3x. That cancels. And I'm left with 6 equals. Cancels. 6. How incredibly interesting. 6 equals 6. That is very profound. Another P word. And today's lesson is brought to you by the letter P, children. Okay, so I could totally subtract 6 from both sides, but it's really not going to matter. 0 equals 0. Well, I could have stopped here. When does 6 equal itself? When does 0 equal 0? When does 3x plus 6 equal 3x plus 6? Where did the x go? X is gone. It left. So I'm a little confused. Let's put a 1 in here. If I put a 1 in here, 1 plus 2 is 3. 3 times 3 is 9. If I put a 1 in here, 3 times 1 is 3 plus 6 is 9. If I put a 2 in here, 2 plus 2 is 4 times 3 is 12. If I put a 2 in here, 3 times 2 is 6 plus 6 is 12. If I put any number in there, including the negatives, this is going to be equal. 6 equals 6 all day long. 0 equals 0 all day long. 3x equals 3x all day long. 3 times the quantity x plus 2 is the same thing as 3x plus 6 all day long. This is how we write it in super proper terms here. I don't think I put 2 lines there. It's been a while. Okay, this is a special symbol. X is X. You're good with that. The E stands for element, as in it's a part of. I'm a part of this. It's an element. And this is called the real numbers. Real numbers are the opposite of imaginary numbers. Believe it or not, imaginary numbers are a thing. So this is the symbol for the set of real numbers. That means X can be anything. Any number, positive, negative, fractions, decimals, irrational numbers. Irrational numbers are the numbers that go on forever, that don't repeat or end. Like pi. I could put pi in there. I'm not a baker, but I could put a pi into substitution because I am a math teacher. Okay, so this is today's lesson. 2 of these are from the notes. You can copy them down. Oops, I forgot to check. I forgot to check it. I did so much of the work already that I forgot to do it. So back to number 7, checking, is rewriting, which I did already. Substitution, which is like rewriting, taking the x out, putting the parentheses in. And the answer was, I'm going to leave it improper, negative 5/3. And then, it goes here too. You guys probably aren't used to putting it in 3 spots. Okay, so then we're going to put this in the calculator. It's negative 10. I think this comes out negative 7. And then when we put this in, hopefully this comes out negative 7 too. If I'm wrong, let me know. Put this in the calculator and see what it comes out, because I know 3 goes into this 2 times. 2 times negative 5 is negative 10. Negative 10 plus 3 is negative 7. That one I can do pretty quick, but my bell just rang, so I'm really running out of time. And then I didn't get a chance to put this one in the calculator, but put this in the calculator and see if it's negative 7. If they're both negative 7, then you know you did it right. See you later.